Hey there, today we're going to be talking about how to use these theorems that we've talked about for parallel lines to find 7 angles when we're only given one. Let's go ahead and let's get started. So here we have 7 angles that are labeled 1 through 7, and we have one angle that we're actually given, that's 40 degrees. And these angles were all created by a set of parallel lines. So here we have 2 parallel lines, and they were called by what we call a transversal. By this line. This creates 8 angles for us, and we've recently covered some theorems that are actually going to help us find what all these angles are by simply using one given angle. So let's go ahead and let's get started. I know that this angle right here is 40 degrees. So let's go ahead and let's discuss what angles could I find by using certain theorems that I've learned already to use this sort of 40 degrees, okay? So the first one that we're going to use is actually one that wasn't even a theorem that we learned before we discussed parallel lines or anything like that. This first theorem is the vertical angles theorem. And the vertical angle theorem says that any 2 vertical angles are congruent. So I know that these 2 angles, and we're going to go ahead and call this labeled angle 8. Okay? So I'm going to call this angle 8. I know that angle 8 has to equal the measurement of angle 5 based on the vertical angles theorem. Okay, so that would tell me that the measurement of angle 5 would also have to be 40 degrees. So this here is also 40 degrees. Based on the vertical angles theorems, any angles that are right there across from each other, those have to be identical. Now what I'm going to do is I also know that corresponding angles have the same exact value. They are also congruent. So angles that are sort of in the same position in each group. So here's what I mean by groups. These upper 4 are their own group, and so are these lower 4. Okay, so angle 8 is in that bottom left position, and its corresponding angle would be angle 4. So these 2 angles right here actually have the same exact measurement. They're congruent by the corresponding angles theorem. So I also know that the measurement of angle 8 is equal to the measurement of angle 8 is equal to the measurement of angle 4, and this is by the corresponding angles theorem. But another angle that is also equal to each other, so I know this would tell me that the measurement of angle 4 is also equal 40 degrees. Okay. But I also know that we have another set of corresponding angles. So by the corresponding angles theorem as well, we know that the measurement of angle 5 also has a corresponding angle of 2. Those are both in the upper right hand side. So these 2 angles are also equal. So I know that the measurement of angle 5 is equal to the measurement of angle 2 by the same theorem, so I don't need to write it again. It's still by the corresponding angles theorem. So that tells me that the measurement of angle 2 is also 40 degrees. And here we see that we found 4 angles just by using theorems. And what you'll see is every time you have parallel lines cut by a transversal, these 4 angles actually always equal to each other. So angle 2, 4, 5, and 8 will always have the same value, typically. Now, how do we begin to find angles 1, 3, 6, and 7? There's actually a few ways that you can do this, and there's 2 theorems that we could use that help us figure this out. One of them could be the linear pairs theorem. The other is a theorem that we recently learned, which is the same side interior angles postulate. Actually, not a theorem, it's a postulate. So let's go ahead and let's talk about that postulate. That postulate says that if I have two angles that are on the same side, okay, so these are four angles are on the same side and these four angles are on the same side. But it says two same side interior angles, so we're talking about they're on the same side and they're on the inside. So for example, like angles 3 and 5, those are on the same side of our transversal and they're in the inside of our parallel lines. These are same side interior angles. We also have another pair of same side interior angles with angles 4 and 6. And what the postulate says is that if you add these two angles up, you should get 180 degrees. Or in other words, that these two angles are supplementary. Okay? So we're going to get these angles, and we know that the measurement of angle 4 plus the measurement of angle 6 should equal 180 degrees. And this is by the same side interior angles postulate. Okay, and this helps me find what the measurement of angle 6 is because I know what the measurement of angle 4 is. The measurement of angle 4 is in fact 40 degrees. Plus the measurement of angle 6, which is unknown, I get 180 degrees. I can simply then subtract the 40 angles from both sides, 40 degrees from both sides, and I get that the measurement of angle 6 is in fact 180 minus 40, that would be 140 degrees. So I know that this angle here is 140 degrees. And what you'll see is that angles 1, 3, 6, and 7 are actually all the same, and we can use the same reasons as we did to find the other angles. By the vertical angles theorem, I know that these two angles have to be the exact same. So I know angle 7 will also be 140 degrees. In the same way, these also now have corresponding angles. They're corresponding angles to angles 1 and 3. Okay, so I know that because of corresponding angle theorems, angles 6 and angle 1, those are congruent. So I know that this has to be 140 degrees. And I also know that angle 3 has to be 140 degrees. And that's how we use one angle to find the other 7 angles when we're dealing with parallel lines that were cut by a transversal. So hopefully now you understand how we can apply these theorems to help us find the angles that are found when we have two parallel lines that are cut by that diagonal line, which we call a transversal. Now, a lot of times these theorems are simply stating that two angles are equal to each other, which makes it pretty simple. You know, there wasn't a lot of math that we actually did in finding these values and these measurements to these angles. A lot of it was just these two are equal. So if one's 40 degrees, they're both 40 degrees. So keep that in mind. Postulates, they require a little bit more work. But again, that was just some simple algebra, one step to help us find out that some of the angles were 140. What I'd like you to do next is to check out these videos that are going to be about the converse of these theorems. Basically, we're able to use these theorems to help us prove that lines are parallel if we take the converse of them. So definitely tune into those videos so that you can kind of learn another way to use these theorems and apply them in a different way. As always, I just want to say thank you for watching, and I hope you found this video helpful.